Welcome, everybody. Tonight is the 14th of November, Dallas Personal Robotics Group. We meet online, and what we're going to do tonight is first we'll have a presentation from Iron Rain, our favorite high school age team, roughly. Then we're going to go around the table with updates on our builds and robots, but we'll also have a little bit of a discussion about the contest that's coming up this coming Saturday, just a few days from now. So with that, I am going to shut up, stop sharing my screen, and pass the mouse over to Iron Rain. The floor is yours. How did it go on this weekend's contest?
Hello, I'm actually not with them on site, but I'm part of the code team for Iron Rain, and we have some kind of cool stuff that we did with odometry that I'd like to talk about. And so, how many of y'all how many of y'all have experimented with odometry and basically a second source of truth for your robot's position?
Oh, maybe I can run.
Yeah, most of us.
Yeah, and so what we did is we implemented kind of a dead wheel system into our robot, which it's essentially we have our normal mechanisms, which are driven by our motors, and then we have dead wheels.
And go to the underside. The dead wheel part of the sorry.
Yeah, so what he's saying is we have 3 other odometry pods that are dead wheels that get no power, but they're just used to basically verify our position on the field. And it's kind of laggy, but you can see them. The big box right in the center of that camera feed is a dead wheel kind of pod, odometry pod, and we got those from GoBuilda.
So, Jai, could I interrupt you for just a second? Since you're talking on some of our computers, that will capture the screen. So, just a reminder to if you're not seeing the robot with the Iron Rain title in the display, what you should do is go over and tap on the push pin to focus your display on the robot. And if you're doing that, you'll see the underside of the Iron Rain robot with its freewheel on the bottom, I guess.
Mm-hmm. And so we got to work, because this is the first time, me personally, that I've experimented with a second source of truth for the robot's position. And we hit a nice landmark as far as odometry goes, and that's what we were kind of looking to show to you today. And so what we were able to do was to get the robot to autocorrect, and so it was driving back and forth. And Mr. Vivi, if you want to show that.
So bad news, the mods that you were making last time have messed up the test op mode, and it's doing really weird things. So we need to, and I don't have time to load up the other one, so we're gonna have to show the video that was posted on the Discord. You want to show that? You can just
I can show that. So,
hopefully there's nothing inflammatory right around that area in the post.
Nah. So I'm gonna go ahead and share my screen now. Can y'all see this?
Yeah.
Yeah. So what this robot is doing is it's essentially trying to follow a path just back and forth across the tile, and we're kind of kicking it around, and it's using the differences measured by those dead wheels to autocorrect itself back onto its path. And yeah, we had maybe like half an hour of just pure fascination at how we just kick around our robot, and it knew exactly where it was, and it would like autocorrect in a really cool way. And yeah, and so this was just us exploring what we could do with odometry, and eventually we want to be able to map this out to our entire game field for our competition. And yeah, I think you can see in the camera feed, but the game field, I don't know how familiar you guys are with it, but it's pretty big, and knowing exactly where you are on that field, especially like with dead wheel level accuracy, is infinitely valuable for us.
Especially when you're trying to go through all of these obstacles on the field.
Yeah.
Are you going to have a chance to put it into use this year?
Oh yeah.
Okay, so the season's still going.
Mm-hmm.
Okay.
The first competition meet is this Saturday.
Oh, okay.
Yeah.
Okay, cool.
So
it's just the competition is just starting now.
Yeah.
Okay, well that's great.
The season goes through January for the initial season.
Is this going to make your autonomous scores really high?
hopefully.
Hopefully. Part of autonomous is scoring on this. It's called the backdrop. So these pixels are the primary element this year. You got to pick them up and you got to put them on the backdrop. Mostly they're coming from the other side of the field, but these right here are April tags. So one of the things they can do with the robot and vision is to each one of there's 8 April tags on the field, and they each have a different ID and a fixed location. So anytime they come near an April tag, one of their goals is to relocalize the robot.
Yeah.
So even if the odometry pods drift a little, they can reset.
That sounds good. That's great.
The goal, anyhow.
Yeah.
So what's the algorithm? I mean, do you just assume that the dead wheel is always correct?
Yeah. So the dead wheels are also they're spring loaded, so they're pressing into the ground. So unless a robot literally ends up flipping over, they should be in contact with the ground, and the encoders on those are very, very reliable. So yeah.
Do you have more than one dead wheel?
Yeah, we have there's 2 wheels per pod, and we have 3 separate pods. We have 2 pods that are parallel with the robot and 1 pod that's perpendicular with the robot. And so we have like a strafe odometry, because our robot strafes and we do turns as well. And so turns and forward and backward motion are determined by the parallel pods, and then the perpendicular motion, which is strafing, is determined by the third odometry pod. And so we use kind of a combination of all 3 of these readings to get a heading, a location, and X and Y.
The parallel ones also give rotation.
Yeah.
They can get rotation from the IMU, but the IMU is on a 7 millisecond lag from the odometry inputs. And that can actually create a problem over time. So, the IMU's gyro can be used for longer term correction. But this year, because we have those April tags all over the place, in locations where the robot wants to go anyhow, trying to use those for localization is probably those are always absolute. Cool. You can even get back, so you can get back to your camera's orientation in regard to the April tags, right? So it's 3 or 6 degree of freedom orientation.
Can you show pictures or video again that shows the layout of these 3 pods?
Well, that wasn't video. That was robots back up on a table now.
I'm on a meeting.
On it. Bring it over
So why do you need 2 on each side for forward and backwards?
There's 2 of them. You can do 2 odometry pods with IMU, or you can use 3 odometry pods where 2 of them are doing translation in one direction plus rotation, because they're on either side of the robot. We'll send you a close up again real quick.
And that's because the platform is differential drive, is that correct?
It's not showing up. It is a Mecanum drive.
Oh,
So it can stray sideways as well. That's why it's got the cross wheel.
all right. So you've just got an Omni wheel on each one, right? So it'll slide in the perpendicular direction and rotate in the inline direction. Is that right?
Yeah.
Well, for some reason my camera's gone dead.
That's what they do.
Yeah.
It's part of the design spec.
I can pull up a photo in just a sec. Or a still from the video and maybe just show you exactly where they are.
It's not seeing it from underneath though, right?
No, it's not.
Do you want me to post a picture in the Discord real quick? Or?
Yeah, I can do that.
So, we have, this is a bad frame. There we go. Okay, so there's one that goes across. Can y'all see my mouse?
Yep.
Yeah, there's one that goes across right under those two motors. And then there's two, like right about here, they go front and back. So there's one on this side, one on that side, and then there's one that goes across right in the middle.
So it's not like these dead wheels are not for redundancy, are they? They're actually just for measuring in different orientations, or are they redundant and overlapping somehow?
So so we just straight up unplugged our native motor encoders because Mecanum is really bad for encoder positions because of just how much slipping there is.
Yeah.
So they are our only source of truth right now. All three odometry pods combined. But because they're so much more reliable than Mecanum, we were just able to just drop Mecanum as far as encoder values coming in goes.
So you close the motors around what computed velocity from the dead wheels?
Yeah. So we just taken basically how many ticks the dead wheel has spun, and then we assume that that's how far the Mecanums have traveled, and we base everything off of that.
Are the dead wheels themselves Mecanums?
No, they're Omnis. So they slide in one. So basically, the one that goes across here, if the robot were to travel forward, it would just slide, and so it wouldn't get an encoder reading. But if the robot were to strafe, it would get an encoder or a change in encoder ticks, right? And so we can basically isolate one axis of movement on each dead wheel odometry pod.
So they're really just slipping. They provide a little drag, but nothing that matters too much in terms of the impeding the motion of the robot.
Oh yeah, no, they're really well lubricated. They're standard Omnis, so they slide really smooth, and especially for how powerful these motors are versus how small the dead wheels actually are. Each pod is about maybe this big, so I'd say like half the size of a motor, maybe half to 3/4 the size of a motor. So they're not huge. They're not necessarily impeding the motion too much.
I see. And the Omni wheel has the roller in line with the axis. Got it. Thank you.
Yeah. Okay. Other question about them. On each side are the two dead wheels perpendicular to each other. Or
so there's one going this. There's one pointing. I'm gonna call the direction that the robot is facing X, and perpendicular to that Y, right? There's two pointing in the X direction that way. So there's one on this side pointing, like measuring motion. Wait.
In the X direction, yeah.
In the X direction.
Hey, look at the pictures on the Discord. Show that.
Yeah. Give me just a second. There we go. That's a much better visual.
How are you showing it?
Yeah.
Oh, okay.
Yeah. So there's one that tracks motion in this direction. So the middle one tracks motion in this direction.
Right.
And then these are both parallel, so they get our robot's heading.
Okay,
So is it-
parallel. You saying on either side or?
Yeah, so on either side
Yeah.
you can see that like the direction of the omnis is
Yep.
like straight up and down. And so they'll capture motion forward and backward or straight up and down in the context of this photo.
And the difference gives you the rotation.
Yeah.
Right, yeah, okay.
Cool. Clever.
Of course, it only works because we're on a really smooth
Oh yeah.
foam surface, right? In the real world, this kind of thing, you'd probably be better off with some sort of optical flow type sensor.
But you said did I hear you did have these dead wheels spring loaded, right?
Yeah, so you can see right there, like that's a spring that's pulling essentially the dead wheel down. It's like on a little hinge. But that spring is loaded and it's pulling the dead wheel down. So on the ground, this dead wheel would actually be pushed into the chassis more.
Yeah.
And it's like depressed, so it's constantly in contact with the ground.
Too bad
Would not expect it to work for outdoors very well.
Yeah. like you can't run this robot on your lawn and be like, oh, it knows where it is now.
Right.
There is a lawnmower, autonomous lawnmower robot that now has Omni wheels at like a 45-degree angle, and that's part of the system.
That just sounds wrong.
It sounds entirely wrong to me. It would have to be a really nice lawn for that to work.
I mean, who needs a grass catcher when you have Omni wheels to pick up the grass?
It's a very expensive mower, too. So yeah, this is not relevant to your meeting, but we wanted to, since y'all we've had discussions about tracking wheels and things like that. We just wanted to show you the stuff. These odometry pods are made by Gobilda. They just came out this year. In fact, they're still in their like first or second shipping. And they cost us $75 each, but they cost a normal person $100 each. So that's a good chunk of change right there.
Yep.
So how? I'm still trying to wrap my brain around in my way of thinking, asymmetry. So it looks like the front. I mean, you can measure rotation when it's moving largely front to back, right, forward or backwards. But when it's strafing sideways, are you able to measure rotational error? So if it accidentally rotates a little bit while it's strafing sideways?
Mm-hmm. Yeah. So
when the one sensor.
Yeah, when these, I mean, we do. I think the control hub, which is essentially our robot's IMU, when that detects a heading change, which it's delayed like by 7 milliseconds, like he said. But when that does detect a rotation, it does get factored in. But also these Omnis, if they're ever not slipping, they're tracking, right? And so if there's a strafe with enough skew to where it's strafing like that, the left encoder is still picking up some change in ticks.
Right.
And so it is getting a heading. Well, it's probably not perfect or not great.
Yeah.
But it does get auto-corrected with like the main IMU and they get factored together with some error.
Over time.
It doesn't matter what orientation your robot is. If there's any rotation, it will show up in the difference between the two parallel encoders. Over time, right? There'll be a changing difference over time between the two parallel encoders.
Yeah.
Otherwise, they should be outputting the exact same value based on the forward, whatever the robot relative forward component is.
Right.
Yeah. How many ticks per rotation do they have? Are they really high res or
These are 2,000.
2000? Yeah. Wow. It's pretty high. So is that primarily a Go Build a platform then, or is it just the dead wheels? I see some.
Now everything else is Rev.
components in there.
Almost everything else is Rev.
Say that again.
Almost everything else is Rev.
Yeah. Does
They
Rev
play-
not have dead wheels like that?
They have Omnis, but they don't. It was just this season that off the shelf and odometry pods have become allowed. And
Oh.
GoBuilder was the first in to come up with a solution that teams wanted.
Ready-made. Huh.
Yeah, it makes it a lot easier. There are, so this isn't the only way to do it, right? There is an actual open source odometry pod. I don't remember what it's called, but I can follow up if people are interested. I can send it to the list. So there's basically 3D printables and a list of parts that you can get.
So these pods, is it just one encoder per pod or two encoders per pod?
It's one.
One. Yeah, okay.
It's only tracking the rotation of the Omnis, not their sideways slipping.
Right. Okay. Okay.
And they're on very nice bearings. The GoBuilder always does their bearings very nicely. So yeah, yeah. Hopefully, they'll be able to update you some more on their progress. One of the concerns is how fast the robot can go, because this year's challenge, you got to cycle a lot. And so making sure that I think these odometry pods will keep up with the fastest speed that we can go, but it's pretty zippy, hopefully.
It seemed pretty zippy just from the kick around and watch it recover test.
Yeah, the recovery was going faster than the kicking or it was just trying to go back and forth. It was all completely autonomous. There was no driver input at all.
It's always fun to screw with control loops and watch them recover themselves when they can.
Yeah.
Yeah.
When they're not underdamped, then it gets even more exciting.
Mm-hmm.
Yeah.
That system was like right after they'd done their initial tuning. And of course, the weight balance on the robot has already changed since then. That was a whole 5 days ago. So, but yeah, so they're gonna have to retune it a few more times as they continue to build out the robot. Because mechanism, the weight balance really does affect things.
No doubt.
Yeah, I don't know if you want to do that too much. If you've seen the Boston Dynamics video of a group of guys abusing a robot and the robot shoots.
Yeah, you can get some lashback on that. People tend to like endow the robot with some victimhood.
And I mean, we've already had a little bit of lashback. I came home that day and I had a cut on my finger from I would spin the robot and then watch it come back to zero heading, because right after we tuned it, that was the coolest thing to me. And so I was just sitting there spinning the robot and watching it go back, and I guess I didn't realize, and I got this little cut. So they're already starting to fight back.
You might want to sanitize it. He may, partnered with biological agents to
Oh God.
seek revenge.
Yeah. Thank you.
It's like the
We
monitor.
didn't want to take up too much of your time. We know that you guys have competition on the top of mind. So, are there any other questions or?
think this is cool. Just cheering you on, and a gold star for Iron Rain.
Yeah.
Yeah.
Thank you.
All right.
Yeah.
Thank you. Thank you for your time.
Yeah, thanks very much. Let us know if we can give any advice, although I think at this time we're just in awe and learning as usual.
Yeah, that's a great show and tell.
Yeah.
Thank you. Thank you.
All right.
All right, take care, guys. Good luck next weekend.
Thanks. Bye. Well, I'm going to hang on and just listen.
All right, cool. Well, next in queue we had Doug D, and then alternately between Scott and Doug P, I guess, discussion on the contest. So Doug D, how's it going in your world this week?
Well, I had another very up and down world. You remember I had these 4 legs that I was putting on, and I got 3 of them on quite nicely, and that was relatively okay. I put my 2 L298Ns in that I had on my shelf to replace the ones that were burned out. In the first 2 motors that I hooked up, there was a lot of snap, crackle, pop, and burning smells.
Ooh.
So that was a bad thing. And after that, I was having a lot of trouble getting anything to respond to the program control. And it was real nip and tuck if I just threw in the whole towel on this puppy. But I'm not a quitter, so I didn't. But I wanted to really bad. But it turns out that putting the other motor controller in, it must have just been a bad controller. I think it happens. And I put the other controller in. I investigated, did I have some wires turned around, or did I have a solder in the wrong place, or what? And it didn't turn out I had anything put together wrong. It just blew. So it must have been something bad on that controller. There was a lot of pulling things apart and then having trouble getting them back together to prove that. But that was eventually done. And I got 3 of the motors tested properly. This one did not test properly. And when I got the wires and the multimeter out, I found out that there is no connection between the 2 go wires, the red and the white that has the plus and minus on it. So clearly I soldered something bad when I soldered my connection on there. The power's not going through, so you'll probably see me pulling that apart yet once again and working on it. I'm done talking. But all of that being said, there's no way this robot's going to be operational this weekend. And that's probably a good thing, because my wife has taken charge of my weekend, and I'm not going to be able to make it to the contest. So you'll be able to see RoboDog. She's got me going to Chi Omega, if you know what that is. I'm the carrier for all the packages she buys. Not to mention, there's probably some impulses for me too. So that was all I had.
Well, thanks for the update. Up and down week, but these things come along, don't they? So
Still working on it.
yeah.
Oh, by the way, the wife was telling me today, she saw a video about a guy that took wheels and motors from those electric bikes that are like 2 wheels and zoom along, and an electric scooter. She says, look at this guy. He got these 2 wheels and this baby carriage he put him on. It's just going crazy. Of course, the wife won't let him put the baby in it, but he's got a remote controlled baby carriage. And I'm thinking, boy, that reminded me of Ray using his wheels from those hoverboards. He said to do that, it'll be better than these stupid little motors I've got. We'll see how that works out. I got to finish the path I'm on before I do something else. One last little update. Next.
That's cool. All right. Well, good deal. All right. Then that takes us to, I think, Scott, you had some questions about the contest. Were they kind of like specific questions, or should we just skip ahead to Doug and ask?
No. I mean, just nothing specific. I know the schedule's been posted. I just didn't know if anything had changed or anything was different.
Scott? No, nothing's different. Schedule on the thing is going to be what we're going to try to do. If you were there last year, it's going to be kind of like that. And so, yeah, my experience has been, you don't want to wake up the Edwards well, or, you know, before dawn. But on the other side of the coin, where there's a time given in the schedule, you probably want to be right there so that you have the maximum amount of time, because it always takes us longer than ever to get set up and started, right? You know, so.
Well, who's competing this year, Ray? Have you got anything ready?
Yep. Got one platform. I'm having some issues with the 4-wheel drive platform, so I have to change some of the machining, and I don't think I have enough time to do it, so I'm going to focus on the other one, 2-wheel drive. So,
Yeah.
I
And
might visit Steve's place and look for roads, bring a shovel. And
make a
I don't know
road.
if you'd appreciate that, but
So one question about the rules, the requirement for a stop switch or safety switch, safety stop switch, and the rules say that there can be a tether. Let's see. It says it may be accomplished with a radio-controlled safety switch or by a rope tether to the robot, with the competitor walking behind the robot holding the tether. Is it going to be required that the tether be attached to an electrical switch of some kind that has some electronic function, or?
Don't worry about it.
Okay.
Now, what I'm trying to say is we've never been really super stringent on the safety rules, partially because we're out at, you know, pretty much it's not like we're going like Seattle where they're doing it down by the Space Needle and stuff like that, you know, where they got tourists and everything.
Okay.
So, but, you know, it's still something,
but it can't go in the water. So
well, that's what I'm trying to say. It's kind of, you know, if you don't have anything, there is the possibility of you know, you losing your robot into the water.
I also suspect these rules would be, especially this tether thing and the kill switch thing, would be much more enforced if we had the Iron Range guys show up with their 200-pound robot, right?
Right. That's another thing.
Well, you know, it also becomes much more important if you can't outrun your robot.
Right.
That too.
The other thing too is if you can kick your robot and instead of it coming back to the line, you just flies it through the air. You know, you get.
So is it safe to say that the safety rules in our case generally are more for the safety of the robot than the safety of anybody else or any property?
Well, they do, but what I'm just trying to say is we're not going to stop anybody from competing because of it. Now, if you do something really dangerous, we might stop you.
Yeah.
But you're going to use Mobot?
I am.
Okay, so he's probably the biggest robot there. I think he's even bigger than Burp. So, you know, I would say, you just have to be careful.
Yep.
Yeah.
Got it. Thank you.
Okay.
turn the mowing part off.
Yeah.
The blades will not be spinning.
Right. Okay.
Yeah. Steve may not like the height at which your mower cut his grass or something. So.
Yeah.
So I'll share just because it's kind of fun, breaking out all the good tech. Let's see.
Well, Doug, are you gonna send out Steve's address to?
Okay, now I'm gonna talk about that specifically. Okay. Yeah.
So this is the so I'll be using RTK GPS as my only navigation mechanism. So this is the with Starlink providing a back channel to get GPS corrections from RTK to go, and then a Wi-Fi antenna providing the corrections to the robot.
Okay, that's cool. They'll be the first RTK competitor. We'll be see how that how it works. That'll be really cool.
If I can get the darn thing going in time.
Yeah.
Well, I was using RTK to go last year. I just happened to set a waypoint across the lake accidentally because I couldn't see my laptop in the sun.
Yeah.
And remember, I ran over the first cone.
Yeah.
And then I tried to go into the lake. Yeah.
Yeah.
Will you bring something, Kareem, this time?
No, he's competing. He's competing.
All right. Yeah, you got your
Iron Rain next week. Yeah.
Iron Rain contest.
Yeah. Otherwise, we were going to show you something. We might still do it. Like we've already sort of captured the video, just haven't put it together yet. But we have a bigger vehicle tracking down a cone, basically.
It wouldn't be an RV van, would it?
Kinda, yeah.
I've seen that on the highway where they come down and hit those cones. Ka-tung, 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 ka-tung.
We had a big cone that's a costume, so somebody can dress up as a traffic cone, and we had it on top of a Tesla, and it was tracking that. Yeah.
Okay, cool. Hey, Scott, are you going to take both your robots or just one?
No, I got them. They're both ready.
Okay. I'm really interested in, I wanted to talk to you. Aren't you using a WIT Motion WT901 on one of your machines?
Yeah, that's on Turd.
Huh?
It seems to work pretty well.
Yeah. How did you? I happen to have a couple, and one of them I got it to be within, after calibrating everything, to about probably one to maybe 1.5 degrees, but the other one, I can't get it to calibrate. And I was wondering, how hard did you find the calibration sequence to get? Did it just calibrate right out?
I never even messed with the calibration. I hooked it up to their software and customized the messages.
You didn't do the calibration routine in the.
No, it seems to be about 8 degrees off.
Okay.
It's
you can do. You might be able to do better than that if you calibrate it.
Well, I mean, I can deal with a consistent offset. I just took that. I just have a variable in software. I can, adjust it. Basically, I do the same thing with belts. That but I mechanically rotate it until it's, and really the way I do it is I just tell it to run the course, and it lines up to where it thinks the cone should be based on the GPS heading. And then I just turn my IMU until it's pointed directly at the cone. And that's really my tuning process. I don't do the moving around and the calibration and all that. It's, it's not practical to throw this thing around like that.
Yeah, well, in theory, if I don't know, that you can always calibrate them in free air, okay, out here somewhere, and then whatever's on your robot might affect it, but at least it's probably going to go 360 degrees. What I have found sometimes is, like, if it's in bad calibration, you might go from, so if you're heading north, you might be, like you say, 10 or 12 degrees off. But what you find when you're going south is that you really can't, it might not ever get to 180. The whole it starts counting back before it gets to 180. So I just, anyway, I was going to show calibration here and see if I was doing anything different, but if you're not doing that, I won't mess with it.
No, I haven't. Now, the thing I have noticed on turd is that it'll go straight for the first cone.
Yeah.
But the second cone, it's like, it kind of wanders around.
Yeah.
But that's why I call it turd. I'm not expecting it to be all that great.
Yeah.
And I've had a lot of trouble with the time of flight sensor array. I haven't really dialed it in good. Because I've been working on 2 different robots, so it's just one of those things that I said, that's good enough. So it's good for some laughs because the obstacle avoidance works really well after you've run into something. And then it'll say, there's something here, I need to back up. And then it'll back up and it'll drive around it. But the next object that gets in front of it, it'll just smack right into it and say, okay, I'll go around you too. And that's something else I haven't quite ironed out. But like I said, for what it is, it should be fine. I've been working on the obstacle avoidance because I've got these new sensors on Belch here, and I've got them working really well. I really like these sensors.
Which ones are those?
Those are the Benawaki, whatever you call it, time of flights. But it's only a 3-degree beam,
right.
So it's a very narrow beam that you're looking at. So you don't get a lot of ground disturbance or faults triggering. They're very stable that way. I was kind of worried that there was a lot of gaps in what you're looking at, but in testing it, even like a decent sized tree, I mean, it'll pick that up just fine and it'll drive right around it.
Yeah.
So I think ultimately I'll probably put another pair on here so I have 5 to get a better field of vision because the wheels hang off so far. I really don't have enough peripheral right now because everything's kind of focused towards the front, so you don't slam into something like turd does.
Okay. So what can which
Oh no.
We lost him.
The deep freeze hit Doug.
Frozen in time.
I've never seen Doug be quiet like this for so long.
Oh, brother, that's evil. That's good. Who wants to imitate Doug?
Yeah.
All right. Well, it's good to see that you're not quite ready, but you're going to be ready. That's exciting.
I kind of went into the software lockdown mode. I'm just kind of testing. Don't try to improve anything and screw it up. So I'm putting, like I was working on the watchdog switch, because I'm doing that through my remote terminal, and kind of an auto start thing on the Linux side. That sort of thing's all I'm really working on right now.
You're just polishing the concrete. You're just making it super smooth and glitzy.
Good software engineering.
Yeah.
Resisting the temptation. That belies some kind of cockiness too, I think, because you haven't taunted Ray lately here, but in this call, but if you're down to auto start so that you only have to click enter once,
No, I don't even want to have to hit enter once. I'm just going to turn the power switch on and hit the button until it go.
All right.
So hopefully that's the idea anyway. So
I've kind of lost track of what we were waiting for Doug to reply on. Should we park that till he gets back, get another topic going, or follow through on this one?
That's fine with me.
So I think
So I got 2 robots. Paul, you've got 1. Ray, you've got 1. Anybody else? Do you know if Doug's got anything ready?
he was working on one, but I don't know if he is ready.
Don't know if it's ready.
So you got, what's your 2 names? The names are yours, Scott, Turd, and Burp?
Yeah.
Any particular order? Okay.
You mean as far as finishing? Probably first and last.
Okay. All right. All right. So then, Ray, does yours have a name?
No, not really.
No name.
Nah.
Paul, have you bequeathed a handle to yours?
It's called Mobot, but you know, I wouldn't say that it's working right now. In fact, you know, I'm still very much in the bring it up after it hasn't run for 2 years, and after I last fried some batteries, and so I got put a new battery in this morning and promptly fried that through plugging in the wrong power plug to the wrong other power plug.
Oh no!
And shorting the 3S LiPo cell, and there was you know, that crackle that you hear when electronics makes its dying gasp, and so I heard that. But fortunately, I'd ordered 2, so I had a backup, and so still trying to get it back operating again. So we'll see how if I end up with something working.
Okay. Well, and at least when I hear sorting out lipos, it's good to see that your usual office is still behind you. It's not a charred ruin. Not like that Tesla in Plano last week, right? That was, yeah.
Ooh, really? So one.
Apparently there was a Tesla X, which is the bigger SUV, and they had just gotten the $9,000 battery repair the day before, and then the day of, I forget the details. They noticed some spinning or something, and got out and noticed that their Tesla was on fire, and somehow the police or the fire brigade managed to pull it out of the garage into the street while it's burning, and they lifted it up and they cooled it down enough that it didn't. I mean, it might have singed the garage, but it didn't burn the house down. It didn't go for as long as that other one I saw recently, where somebody tried to launch their jet skis with the Tesla, so they backed the Tesla into the lake, which really didn't work very well because it shorted out, and then they showed this Tesla soaking in the lake, just smoldering for 2 days.
Oh no. Yeah, I think the don't drown, turn around is applies to Teslas.
Yeah.
Don't go through deep water.
Okay, so Mike, I see your email in the chat. What we'll do is we'll get that to Doug so he can get you the address for the contest, but then we'll pull your email before the chat goes to the web. So.
Oh, okay. All right, thanks.
Yep. So if anybody else would like to do the same thing and just make sure that they get the address, feel free to drop it in there, and we'll clean up the chat. I think I have phone numbers, or many of you have my phone number anyhow already, and once I'm reminded, I can share it with you.
Hey! If you're doing that, Carl, turn off your chat view, because if they put it in chat, it'll go into the recording.
Oh yeah, the chat view's off. Thank you. Good catch.
Okay, because I didn't do that, and we put email, and it took me a pile of time to get all the email out of the.
Oh, that's ugly. Yeah. No, our recordings never show the chat window directly.
Okay, cool.
At least intentionally. It's not tonight.
Okay. Yeah. So before I froze up there, I wanted to say that if you'd send me the email, or I'll use your email in chat, whatever. You don't have to have a robot to come see the competition. if you can possibly make it, we strongly encourage you to come, because it's a good time for everybody to see everybody in person, and it's a good time. It's really a good time.
Yeah.
And food, and there's free food too. So I mean.
So remind me of the time when we went to get there, roughly.
Well, it's on the.
Okay, I'll look there.
Yeah, it's on the competition
I
page.
didn't know if it was like 9, 10.
I'll just pull it up so we can review it, and
Okay.
we'll have that.
And then the other question, should I bring a chair or two or a table or two?
Yeah, if you're running, definitely.
I'm not running, but I can bring
a chair. Bring a chair. Yeah, that's probably a good idea. Okay, so we're gonna. It says like, okay, at 9 o'clock, the judges will lay out the course and provide contestants with GPS coordinates. All right, so at 9 o'clock is probably when you want to get there. Like I said, because it always takes longer than we think. If we get started by 10:30, everything's cool. And then after, well, wait a minute, let's see. Okay, 10:30. I guess you could get there at 10:30 because we start at 12:30. But you want to get there for lunch, you got to be there at 11:45. And like I say, if you can get there early, that's great because we can probably use your help. Okay. Yeah. And that's the mug for this year. So, okay, so is there any questions about the competition? Anybody?
So you're not going to give out the GPS coordinates until the morning of, right?
Because we won't know them until 10:30.
Okay.
Yeah, we won't know what they are. Because, I'll go down there. Basically what'll happen, I'll go out, get with Steve and, everybody else is helping us. We'll kind of like look at the ground and try to figure out how we can put the cones. And we'll put the cones out and then we'll do we'll do it.
Do you provide the coordinates in UTM or LLA?
Degrees and decimal degrees, right?
That's what we'll be shooting for. Because now I'm trying to think of my GPS that I use to get the coordinates. I believe gives it in minutes and seconds, but that's not too hard to change it.
That's my question. Thank you.
Yeah. So. And let's see.
So it is degrees and decimal degrees.
Well, on my program, I know I need degrees and percent of degrees. The fraction parts. Yeah, so, those numbers will be available.
Okay.
But, yeah. Okay. And let's see. Oh, I had something I wanted to share. Let me share this. Everybody knows that I'm having a hard time right now. My wife's health is not very good. But I'm hoping that I can get down to the competition and at least get a point because I really want to get a mug. So figure out how to do that. And I've been working on my. I'll show a couple of things here. Let me see. Sure. Let me share this here.
Okay. How many people think Doug should just get a mug because he's done all the work for the mugs and the designs and
That's okay.
Let's give him a mug.
Yeah. Here we go. This is so from the platform that I showed you last week. this is significantly different because I was very naive about how I was connecting these wheels. So you can see, if you know this right now, you can see that I've put a 3-to-1 pulley here on the wheel, and I've gone to a 10 millimeter belt. And you also notice over here that the hub now looks like a washer on the end with a couple of screws in it. So when I first ran this test thing on the backyard, and this is my yard, so it's kind of a worst case scenario. The first thing that happened was I couldn't keep the belt from the motor tight enough, and it would keep slipping. And then, so I put this change on it. And then the next thing that happened was I had originally put a quarter inch square shaft in a round hole that goes through the middle of these hubs. Well, there was enough torque that it actually caused that to turn in there. So I was faced with do I go in and glue these suckers in or something to try to give me some more strength, or do I seriously go in and put in a proper hub? Well, I went ahead and put a proper hub. So the quarter inch thing is still there, but it's really pretty much just providing me, you're centered upright. So when I run this, listen to the clicking noises. Wherever you hear a clicking noise, that's when I'm slipping on this belt. So should I have had a 10 millimeter belt? Yeah, I should, but I couldn't get a 10 millimeter belt until after the competition. And I may, if I get through the electronics enough, I may go ahead and actually make my own 10 millimeter belt. But let's see if I can get this to play. Why is it? So that's my top speed pretty much.
Okay, guys, I got a big bad with you. Just carry on.
Okay, so here you can see it. It made that.
It's going to scale the fence next, right?
And I don't know if you can hear it, but there might be a little bit of clicking going on here.
No.
Well, I think it goes faster than Mobot.
Yeah. There, you heard it there. And here I get hung up. But you can see the belt. The belt, it's actually hanging on the belt right now. So the wheel, that was bigger than half this wheel, basically. So I couldn't get there. So anyway, that was my little demo. And
what exactly size belt are you missing?
610 millimeter. So
by a 9 millimeter belt, 9 millimeter wide.
Well, 9 or 10. I was going to buy a 10, but the problem I had was
pitch.
Pitch is GT2.
That's just a type. It's not the pitch. Is it a 2 millimeter pitch or a 3?
Probably a 2.
2 is like the finer, like you see on a 3D. It's the smaller 3D printers.
Probably. Yeah, Probably. Yeah. Yeah. So I knew I took to heart what you said earlier about, that I should be using 10 millimeter belts, but I couldn't find any source of them that would get them to me in time. So I have some 10 millimeter open belt that I could make a belt. And that's what I'm going to, like I say, I've put it at the bottom because you saw the platform move.
Yeah.
So it should be able to do, and it doesn't seem to slip when it's going forward. So, if I'm shooting for that first cone, should be able to get to it without too much trouble.
So you said you could make a belt?
Vex carry belts.
Huh?
Vex carries belts locally, and so does Rev. Vex is in Greenville, and it usually ships same week locally here. And Rev has it as well, but Rev only does the 3mm pitch.
Yeah.
It's possible Vex only does 3mm pitch also. I'm not sure.
Yeah. I'll have to look.
You were talking about 5 last time. 5mm?
No, the most common belt that you can get off of Amazon very easily is a 6mm belt.
That's the width. That's but a 6mm belt will be a 2mm pitch.
Right.
3mm belts are usually a 9mm wide.
Yeah. So anyway, I'm just saying it's just going to have to figure out. What I'm saying is I went into this a little more naively than I thought I was going to be. But like I say, it rolls and it works. So, and I might luck out of it. And it was fun because I found out how difficult getting shafting correct is because, I had to I was using skateboard bearings and I'm using, all of the bores of every pulley I ever had was wrong because I had ordered the wrong pulley bore. And so anyway, we overcame a lot of things to get where you're saying. So now, and I have got the superstructure, and I think I've showed you that. What I'm really working on now is this. If you pin me, you can see it. It's my sensor, pretty much my main sensor array, and it sits up on a shaft, on a mass. So right now I added this year one of these WIT EMA motion sensors on the top, and so we're going to see, and I'm also going to have a compass available to me that I didn't have last year, a free compass, just a compass. So I'm kind of curious to see which one actually gives the best heading, we'll see. So that's where I'm working and that's where I'm concentrating on right now. My goal is to go down to the first cone, stop. Ideally hit cone, stop, but we'll see. And, you never know. I look at Iron Rain, I know they're a team, but they get a lot done in a week. We'll see. So that means if you guys all peter out without hitting the first cone, I still got a chance. And I've seen things like that happen. So we'll see how it goes. Anyway, so I'm pretty stoked. I want to see this competition. I want to see it next year, guys. I'm gonna get it next year, but we'll see what happens. That's all I had, Carl. Is he? Oh, he's still on his phone call. Well, who was supposed to talk next?
I don't know if there was anybody. I did get out I think I can show it to you. I got, was kind of curious about, it's kind of like you work on something, you run into a problem, and it's like, oh God, I'm going to have to, work on that for a while to get it fixed. So you think, okay, maybe it was an easier solution going off to some other drive mechanism, so got out the little hoverboard again, and I had written down some of the documentation, but I wasn't certain how many. It actually has a tachometer output, and I couldn't remember what the number of pulses were, so I threw this together just to get, like for a certain PWM duty cycle, what the number of pulses were, and just in hertz. And then I wanted to figure out, how many pulses per revolution. And basically, you just spin the wheel and count it without it being driven. and it'll give you the pulse train, and so you can count the pulses. So it's 48 per, per revolution.
Yeah. And, it's just measuring the pulses off the synchronous motor. I mean, the brushless motor, right?
Yeah. Well, actually, there is an output from the brushless motor. It does some weird things. It's like a high frequency square wave that bounces all over the place. It's like centered around 0 volts. So I'm assuming it was supposed to be AC coupled, and it looks like that high frequency waveform actually varies in duty cycle. The pulse gets a little fatter the faster it goes. And so I'm guessing, the way this was supposed to work was you're supposed to do a pulse width measurement, like on a pulse in or something.
Mm-hmm.
And that was your speed.
Right.
So, but it's a weird looking waveform. I think it was meant to be, AC coupled, because it does fluctuate around 0 volts, positive and negative around 0 volts. And, that's as far as I can tell you. There's no documentation with the hoverboard, because I'm sure they don't want you hacking the thing.
Yeah.
But
just as a sideline with not too much knowledge, I was looking at some hoverboard motor videos on the YouTube today, and they have 3 Hall effect sensors on them. And they said something about lining up the 3 Hall effects to the 3 inputs.
3 phases, yeah.
So you've seen all that already.
Yeah, you have to do it, otherwise the thing won't spin. So you've got 8 combinations with 3 wires.
A couple of the videos I saw, they had bought this Chinese motor controller that they just plugged the things into and it worked. I don't know which one it was. I couldn't see right away on the videos. I saw a number on it, but
yeah, I had to play with mine to get it right. Otherwise, it just makes a noise and draws a lot of current. And they say to reduce the voltage and have a current limiting supply so that you don't fry the driver.
Right.
But hoverboard motors. Let's see if I can get this to spin up here. Spin pretty fast.
Yeah.
A lot faster than. I think they must limit the speed on the thing, because, this thing whips right along, and it's supposed to go. I think they said 6 miles an hour. I don't know how fast it's going, but it seems a lot faster than 6 miles an hour. Hold on a second. I gotta open Arduino here. Come on.
Yeah, my understanding is that 4 miles an hour is a fast walk.
Yeah,
Tell us, Carl.
fast.
Tell us, Carl. Was that it? You're muted.
I'm apparently a grandpap now, so but we don't know the name or the sex or the size of the weight of the baby because there's a slight complication. So until mommy gets out of surgery and they can tell us together, then and that's when we'll learn the details.
Congratulations.
Yeah.
Well, congrats there.
Exciting. Fun times.
Okay, where is open recent?
Ray's busy showing us something about his hoverboard motors.
Oh, good.
Yeah, I was trying to find the right sketch here. Okay, there it is. Okay.
I'm still pretty jealous of your hoverboard motors. I have been to about 6 different ones of those places and never found a single one.
Oh, really?
You got them
Yeah,
all.
I haven't found, I found 2 pretty close to each other. And then none since, so. Okay. Where is the port? Tools. Okay, there it is. It's actually COM11. Okay. Got that running. Okay, I'm going to present. Screen. That. Share. Share. There we go. Okay. Can you see the sketch?
Mm-hmm.
Yep.
Okay. Anyway, it's pretty simple. It's just, generating reading the value off of a potentiometer analog pin and just writing that out to the screen. And then I was actually using a scope to, look the waveform out. Let's see here. Don't know if you can probably see that yet. You see it? Yep. Yeah, there it is. There's the wheel rotating. Okay, so
I can't see it.
Oh, this over here? You don't see that?
We see your code, and that's it. Oh, we'd have to pin your screen then.
Yeah, pin me.
So you want us to pin the you login that's talking, not the you presenting.
Well, we got them both. Just they'll go side to side.
Okay, so you can see the.
I see the wheel spinning. Yeah.
Yeah. Anyway, so that's like a duty cycle of 59. I don't even know if you'll see it when it spins that fast.
Yeah, it's visible.
Anyway, that's 255. I mean, that thing is screaming right along. So I don't know if it would actually make a.
That's what.
And okay, at that rate, I'm only driving it with 12 volts. I could drive it with a 5S battery. It's only drawing 3/4 of an amp. But it's just, spinning and it's not on the ground propelling itself. But the thing just whips right along, so very fast.
And the light show is cool.
Yeah, that's. I guess I could disable that if I tore open the wheel and yanked it out, but.
Don't you dare! Them lights is what makes it go faster.
Maybe.
Yeah.
Don't know. Anyway, the thing spins very fast. I don't know if it would probably be mostly in the air if it was, going that fast down the Steve's lawn. So
that's really cool. I like that.
Maybe even catch air. I don't know. But I certainly couldn't keep up with it if it actually spins that fast on the ground. So.
Make sure you have a kill switch.
Yeah. Just keep it out of the road, that's and the lake, I think. Yeah, you don't want it to crest the hill going after that last cone and get flattened by a big, diesel truck or something.
Well, since Ray just did a demo, if there's no one else in line, I've got a little demo I can show.
Sure.
I pulled up a video of Belch too, with the obstacle avoidance I can show as well.
Cool.
Okay. So.
You want to stop sharing, Ray?
Okay, so you should be seeing my screen. And so this is this demo is so I was down in New Zealand visiting my sister last couple of weeks, and I was like looking around, and I was reading up David Anderson's navigation code and thinking about how to code it up and everything. And then I started looking at my files, and I found a file where I'd actually implemented it like several years ago, apparently, and forgotten it. So anyway, I had that code, it turns out. I didn't really realize it. And so I have a bunch of scripts in this directory, which I probably need to make bigger. So this is a script that I'm about to run in simulation. So there's this runner.py that takes a command from a little language that it understands. So nav means navigate using whatever XY coordinate frame is in place on the robot, to 0, 1, then to 3, 1, then to -1, -3, and then it runs a stop for 5 seconds command, then move odometry -2, and then navigate to 0, 0, and then stop. So so this is really how I checked out, and so it's navigating to 0, 1 there. So it's arrived. Then it goes off to 3, 1. So anyway, this is how I checked out the logic, navigation logic in simulation. So we have yet to see whether it will. So that was at 3, 1. We have yet to see whether it'll work on the real robot, feeding it RTK GPS, but we'll see. Now it's on its way to -1, -3. And then it does a stop for 5 seconds, which would be where it stops at the cone and waits, maybe it's touching it, maybe it's not, but it'll wait the required time. Then it backs up 2 meters, which would be, get clear of the cone and start aiming for the next one. Then it navigates to 0, 0.
So is this using simulated odometry, or where are you getting your position from?
Correct. Simulated odometry, so the wheels output their current position in radians. It gets converted to odometry counts, I believe, in the interface to Gazebo. So anyway, that's just like developing robots in simulation.
It always works in simulation.
Yeah.
But not always, right? If your logic.
Not always, and the idea of simulation is you make it work in simulation, then hopefully you have a better chance at the real world. Whereas if you try
ironing out any silly bugs.
Paul, what was the antenna, the Starlink antenna, sitting on? Was it just a?
It's just sitting on its storage box. So the box came in, I repurposed that as its storage box, and then the box behind it is my Starlink on battery box with a LiPo and a solar LiPo battery and LFP battery and a solar charger and a 12-volt charger and a router in it, and the router feeds, obviously connects the Wi-Fi antenna.
Kind of sounds like you got to cart around a whole micro center worth of stuff.
Well, yeah, and that's a bit embarrassing because one of my friends pointed out that I could have done all that with a cell phone.
Yeah, that's what we use.
I was like, yeah, But it's built.
But it's Starlink.
Well, it's what I take on the road in the RV to give me Starlink when we're out in the boondocks.
Sure.
And so I was like, well, internet forever.
The trouble is you still need an RTK to go station somewhere, within 10 miles, something like that.
Well, the nearest one I've found is about midway between Dallas and Fort Worth, somewhere in the Flower Mound area. So that's probably more than 10 miles, but I don't think it's terribly sensitive to the distance to the. I mean, at most I'll lose a little bit of precision, but probably not enough that it would matter for this application.
Yeah, there's a lot of people doing long baseline RTK up to 50 miles these days. Yeah.
So the batteries that you used in that setup, were they the ones from your RV or?
No, I got a different LFP battery for the Starlink battery box.
Oh, okay. How did I was kind of curious how your batteries for your RV worked out. I know you got like a Chinese knockoff, right?
Yeah, and they're going great. They've been in service for about 3 years now, and they seem to hold. Well, it's been a while since I tested them, but when I first built it, they tested at 280 amp hours, and
okay.
They still run the RV for 2.5 days. So nothing's really degraded that I can tell.
Yeah, I think if any, is yours? Does it have 2 axles or 3 axles?
2 axles.
Oh, 2. Yeah, that's kind of the tiny home size. That is, that thing is huge. I have a Casita. The whole body is, well, it's supposed to be a 16-foot, but that's from the front of the trailer hitch to the back bumper. The actual bubble that you live in is only 13 feet. So,
that's
considerably smaller.
Well, but you wouldn't go out for 3 months in that thing.
Probably not. No. Yeah.
But that layout is nice. That Casilla layout is nice because I bet I have the same layout. So yeah, even though it's small, it's roomy.
Yeah, they made pretty good use of the space, I think. All the cabinets and benches are fiberglass, so it's very lightweight.
I had a paper. Oh, wait, never mind.
So anyway, that was all I had. I think Scott had some videos he was going to share.
Yep. Supposedly.
Nice.
So like you can see, it seems to pick up obstacles pretty well. Although in this particular run, it misses the cone. So it has to kind of look around for the cone. It's like, oh, there it is. Oh, hi, how are you?
Nice.
So I think we got another one here.
Well, there was a hard target.
Yeah, I'm gonna have to. I had to stop it because it's going towards a retaining wall. But here it's driving around a tree, going back to finding the cone. So I'm really happy with how the obstacle avoidance is working right now.
So how many Benewakis do you have on the thing? 2 or 3?
There's 3.
Oh, wow.
They have a left, a right, and a center.
Yeah. So you have them far enough apart that the beams don't overlap?
Well, it's only a 3-degree cone. So
yeah.
You can see, here, let me stop it here. You can kind of see that they're angled. Yeah, so they're all on different, trajectories, if you will. The center one's going straight forward, and then the 2 side ones are kind of angled.
Mm-hmm.
So it goes around this other tree up here. So that's what I was saying. It doesn't really have enough peripheral vision. But it keeps trying. And eventually...
I can try to find them.
So... That's my videos.
How did it know to back up when it ran into the tree and lifted off when it didn't on the tree trunk that it hadn't seen?
I have a tilt limit.
Okay.
So
cool.
it knows it monitors its pitch, its roll.
Yeah.
If it gets out, I think it's 20 degrees or 30 degrees. If it gets more than that, then it'll actually stop the motors. And it'll back up, trying to, because the idea being is that you're always going to run into something going forward is the idea. So that's what it was doing. It was just the tilt was going too excessive. That's what actually stopped it. And then the collision logic said, okay, well, I need to back up.
Yeah.
So, like I said, that's why I want a little bit wider field of vision, so that I don't run into trees like that. And that's, it turns out that's why I put the little, it's very advantageous to put the IMU stanchion on the back like that so it doesn't just fall over on its top. That seems to have worked out pretty well in my favor.
So that's like the anti-wheelie bars in the back there?
Yeah.
Anti-flip over bar, maybe?
Yeah, that's the wheelie bar.
So is that thing stiff enough to take that though? When it's possible it'll break or?
No, it's a sprinkler riser pipe, so it's like heavy duty PVC.
Oh, yeah.
It's probably, I don't know, almost a 1/4 inch thick PVC. And it's threaded on. I mean, it's all sprinkler parts because the riser's a sprinkler riser, and then the enclosure is actually a sprinkler head box or cavity, and then the cap to it is actually a PVC cap. So yeah, it's all plumbing parts. You can go to Home Depot and build this robot. Home Depot and Mauser. You'd pretty much have it all. So that's all I got. Hopefully it'd be enough to win this weekend. Or at least beat Ray. Either way.
Come on, Ray. Come on, Ray. Come back with something snappy.
I got nothing. I don't know what to tell you.
Yeah, well, all I can say is Paul, he's the dark horse now. He's using that high-tech RTK technology. Who knows?
You know, you should never be too confident because robots will find a way to break, or the configuration will be different in some way that you didn't anticipate.
I heard somebody new was going to show up. They might just take it all.
Yep.
Isn't this Mike's first time?
Oh, Mike Williamson?
Yeah, didn't he say he was coming?
He coming, but
Coming, I didn't.
I'm gonna come and look, and I'm gonna come and cheer you on.
Oh.
Yeah.
I thought you might just show up with a robot and make them all look bad.
I got a couple days. But I start now.
Well, it's not till Saturday. You got 3 whole days left.
Well, a quick update while we're not talking about anything. I got my leg all taken apart. Found out that you probably can't really see that, but on the top of the motor, there used to be this cover. That's the sensors, the encoder sensors. This encoder broke off, and that's a cut in half wire right here, but that's not in the motor control wires. That's in the encoder wires, which weren't hooked up. So I couldn't figure out why is it not running. So while it was all apart, I hooked it up, and it could be that maybe this plug here was just out, because when I pulled the motor out, that plug was not attached. So 4 motors running, one of them has a bum encoder. Well, that was my quick update for what I discovered today while I was listening.
Sounds like things are getting better.
Well, moving forward at least. It was real close to the trash can last weekend.
Yeah, I know what you mean.
I still have to buy some more motor drivers like we talked about last time, some of those new ones probably, because now I'm down to only one L298 and I need 2. So I either have to buy more of those or buy some of those new fancier ones that can take more. I'm probably going to go with the new ones. What the heck? I'm not in a hurry. Wait for them to get here.
Yep, you just need 2 of those, right? You could hook your 2 motors in parallel.
Well, I'm going to order more than 2 because I've had a bad habit of cooking them, and I need a replacement quick. And there's always the next robot.
You blow one up.
Yeah, I think I saw a package of 5 somewhere. I did read in the comments from people that a lot of them are coming in with bent pins, like their quality control is not very good.
Yeah.
And so it's good to have a few extras just in case, right?
Yep.
Well, I noticed, Doug, that your, or it looks like anyway, your motor leads seem quite long.
They're very long. Yeah, I had a problem with them being too short when I had them. I was using DuPont connectors, and they were barely making it to the Arduino. So I made them really long, and I'm going to cut them to size once I get things in position.
That can cause all kinds of havoc on an H-bridge, especially when you're switching them. You can create a lot of noise, and can wreak havoc on H-bridges.
That's good to know.
You may want to try to optimize those as you're putting it together and try to shorten them as much as possible.
Can you go twist and pair to cut down that noise?
You can, that'll help a little bit. Wrapping around ferric beads will help. The most effective way is to cut every millimeter of length out of that wire you can.
Yeah, I will do that.
Even if you put your H-bridge drivers in your little wheel assembly or your leg assembly, and then just run the signal wires to it.
That's an idea. I've got about 12 inches between the motor and the H-bridge.
Does that motor have capacitors to ground on either side of the motor? The motor wires?
No.
No, yeah, that's another thing that you can do to reduce noise.
That works.
Sometimes I'll have one to ground on both the positive and negative leads of the motor to ground, and then sometimes between the positive and negative, a small capacitor.
Really?
So
Yeah, that helps with commutation noise.
right.
Basically, the brushes, the switching noise of the brushes as they go from one commutator bar to the next.
Interesting. I never would have thought of that. I would have thought that would be a shorting type thing. Well, I guess the capacitor keeps it from shorting.
Yeah,
Yeah, it's
that really works good though. I've had that where I had something that didn't work. I did put capacitor. The first thing I do is put capacitors on the motor, and that often solves the problem.
Well, good to know. You guys are a wealth of knowledge. I'm glad I'm here.
Yeah, a lot of the Polulu motors and the make block motors, they will already have those on there on the back of the motor. So
Yeah,
you might have them.
See the back of this motor, and it is not there.
Nothing there.
Take a look at your encoder. It might be on your encoder.
I don't know if there's a good enough here.
Can you see capacitors on your computer? No, none on there.
Over here. Is that a clear enough shot? You can see there's the white connector. There's two pins sticking up on either side that don't go to anything. And then there's the two encoder things. There's definitely no capacitors up there.
There's no,
Yeah, there's some surface mount components on the other side though, right?
Yeah, that's one of the encoders there. And this is just a pin sticking up for who knows what reason.
Oh, okay.
And then there's 4 solder things there, which must be some wires underneath doing some kind of connection.
Huh.
Well, the two big tabs are going to be your armature connections, and they're going to connect to that white connector through the PCB.
Right.
And Ray's probably right. There's probably surface mount components on the bottom side.
Could be.
Yeah.
Because I see, it's probably hard for y'all to see at the bottom of the picture, there's 4 little solder tabs.
Yeah.
Solder spots for underneath. Cheap Chinese motors. Not too cheap. They were $25 a motor. But anyway, I'll try some capacitors and see if that helps.
Yeah. Let me show you here. Yeah. Here's one of those. It's just a little make block motor, and on the back of it, see if we can. There's 2 capacitors to the frame of the motor, and then one between, the 2 legs of the armature. And yeah, so that's, and this doesn't have an encoder on the back of it. So, but there'll be. It seems like everything's surface mount now. I don't know that many manufacturers are using discretes anymore, or through hole components. But anyway, makes it a little quieter.
Carl's back. Did you get the rest of the info?
Yeah, so the baby's name is Johanna Therese, and 18 and a half inches long, 7 pounds, 2 ounces. Mom and baby doing well.
That was the piece we needed.
And I will leave in about 10 minutes because we have a FaceTime with the new family. So
cool.
I'm done.
I was thinking,
you got a new name, Grandpa.
Yeah, I think I'm going to go with Grandpap if they'll have it. But we'll see.
Your hair looks a little grayer from earlier tonight.
Yeah, well, what's left of it.
Yeah, I know what you mean.
And after the recording, maybe next week after the recording, there won't be time tonight, but anybody interested in my lessons learned from identity theft, I'm happy to go through that and some tips and tricks to get the credit reporting agencies.
Or maybe Saturday.
Yeah, maybe Saturday too, sure. But
Especially tips about avoiding it. Yeah.
Yeah. Well, that's what I have. Well, after we stop the recording, I can put some links in this chat if I'm still here. But
you can do it next week.
Yeah.
You got to.
Yeah, I guess if it's credit cards, don't store any credit card information on, in your computer, on your phone.
Well, it's the whole. Anyhow, this is.
So you get it. So
there's 5 different web links that are seared in my brain now that are good to take proactive action on. So, and it's worth an hour or two to do it, I think. Not that. Yeah, in this case, it's not clear that was the problem, but.
Well, you give those credit card numbers to just any high school dropout that you see at a restaurant and stuff. You never know where those numbers are going.
I don't think it was that. This was a case where I got a alleged letter from an alleged debt collector, but it's a loan I never took out. But it's threatening a lawsuit, and
yeah, I don't know if I would have answered that letter. That could have been a phishing attempt.
That's partially why you're not supposed to. Yes.
It had enough personally identifiable stuff in there that yeah.
But the key is they have the information so they could have generated the loan without him actually doing it. So yeah, it can be a problem.
Yeah.
So were your Plano police any help or?
Well, if we're done with this, shall I stop the recording? I'm going to talk for a few minutes.
Sure. Yeah, I'm kind of curious.
Okay, enough for the night's recording. And then I'll just give a brief update, but then I have to leave for a